Today we are going to discuss another method for finding the roots of an equation that is called the method of falsy position or regular falsy method. Consider the equation f of x equals to 0. Let's suppose f of a and f of b are of opposite signs. Then this means that the root lies between a and b. Consider the graph x-axis, this is our positive x-axis, this is our negative x-axis, positive y-axis and negative y-axis. These are the 2 points where the values of function are different behavior. Let's suppose this is our point f of a, that is basically positive, so I have made this point above the x-axis on the positive y-axis, and the point f of b over here on the negative y-axis. I am drawing the curve for y is equals to f of x. For example, this is the curve for y equals f of x. This curve y is equals f of x is basically cutting the x-axis at one point, and our purpose is to find out that point where f of x comes out to be equal 0. And for finding this point approximate root, that is basically the approximate root. For finding this approximate root, we are basically deriving the formula for finding this approximate root of the equation. I will draw a line from point to this point. That is basically the chord from point A, and A, the coordinates of point A are A, f of A, and the coordinates of point B are B, f of B. I have joined the point A and B. That line is basically called the chord joining the point A and B. I will derive this formula for finding the approximate root by finding the equation of chord. Equation of chord joining the points A and B will be, we will use the general equation for 2 points. The general equation for given 2 points is basically y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. I will use this general equation for 2 points and find out the value equation for this chord. The equation for this chord will become y minus f of a over x minus a. This is basically representing x1, y1, and this is basically x2 and y2. Replace these values in this general equation. I will get y minus f of a over x minus a equals f of b minus f of a over b minus a. Name this equation as equation 1. The chord, we have seen that the chord is meeting the x-axis at point y equals to 0. The chord meets the x-axis at point x equals to x1 and y equals to 0. Name this point as x1. So basically, I will use x equals to x1 and y equals to 0 in this equation number 1. Put these value in equation 1. In place of y, I will put 0, and in place of x, I will use x1. I will cross multiply the equation. This x1 minus a is moved on the right hand side, and this b minus a is multiplied on the left hand side. I got minus of f of a, b minus a equals f of b minus f of a multiplied with x1 minus a. Now open these brackets. I got f of a is multiplied with b. I got minus b f of a, and then it is multiplied with a. I got plus a f of a. Then open these two brackets as well, the normal multiplication that we follow, that will become x1 f of b minus x1 f of a, minus a f of b plus a f of a. Now rearrange this equation. The terms which involve x1 are left on the right hand side and all other terms are moved on the left hand side. Plus a f of a and minus a f of a both have opposite signs and both values are same, so I cancel these values. So I got a f of b minus b f of a, that is equals to x1. I got common x1 from this right hand side and I will get x1 multiply with f of b minus f of a. Now to separate this value for x1, this multiplying bracket will divide over left hand side and I got a f of b minus b f of a over f of b minus f of a equals to x1. So this is x1 equals to a f of b minus b f of a over f of b minus f of a. This is basically the first approximated root. For finding the second approximate root, we have 2 points, that was basically a and b we discussed earlier, and the curve, this curve is for y equals to f of x. Now we got first approximated value, that is x1. So this point that is touching the y is equals to f of x, the curve will become x1 f of x1. Now we will observe the behavior of f of a, f of x1 and f of b. If f of a and f of x1 are of opposite signs, then this shows that the root will lie between a and x1. If f of a is positive and f of x1 is negative, then my root will lie between a and this point. So the equation of chord will remain between the point a and c. So my second approximated value will be between a and c. That will be a f of x1 minus x1 f of a over f of x1 minus f of a. This portion will be discarded since my root is lying between a and x1. But if f of x1 and f of b are of opposite sign, then my root will lie between c and b. So the equation of chord will I will consider the equation of chord will between c and b. And my second approximate value will become x2 equals x1 f of b minus b f of x1 over f of b minus f of x1. So our choice of taking the approximate will depend upon the behavior of the functions. In the same way, we get x3, x4 up to so on till we get the required root nearer to the root of the equation f of x equals to 0. In the second video, we will discuss an equation, an example using this method. So subscribe the channel so that you can get the updates regarding the next videos.